Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
Our goal is to run my application right inside a Kubernetes cluster, which will be running as a container again, right? But I'm going to get a lot of add-on advantages rather running the container as a native Docker method, right? The Kubernetes as a orchestration engine going to give us some flexible features which will improve the way how we can run the application in a container, which includes some of the best practices that I talked about, right? Like load balancing, high availability, scalability, service discovery, health checking. There are a few other. So let's see how do we deploy the Kubernetes cluster and how do we run the application there and how to access the application from outside world. That's the goal, right? Good. So it's not so easy or it's not a straightforward, guys, to deploy the Kubernetes cluster, as you have already seen that Kubernetes is one of the biggest architecture that you can come across compared to any other tools or any other things, right? And setting up this whole Kubernetes cluster will definitely a significant amount of time, and there are a lot of steps that we need to go through, right? So as the engineers are feeling difficulty to set up the Kubernetes cluster from scratch, it starts from creating EC2 instances, installing the required Kubernetes packages, bring up the services, put the network connectivity, right? All of this. So it takes some time. So hence the reason the cloud providers like AWS are offering a managed Kubernetes clusters. What does it mean by the managed Kubernetes cluster, right? When I say managed Kubernetes cluster, right, the whole Kubernetes cluster infrastructure related components. What is the Kubernetes infrastructure components, guys? When I say a Kubernetes infrastructure component, it includes your control plane plus and the worker nodes and the networking connectivity between the nodes that you have in your cluster, right? And pretty much deploying and bringing the Kubernetes up and running, right? That is whatever is involved in terms of right setting up the Kubernetes cluster from scratch. The whole stuff is now available as a managed service, in the sense anyway you are going to take the EC2 instances from AWS, right? Now we can even ask the AWS that, hey AWS, when you are giving me EC2 instances, can you only take care of installing the Kubernetes softwares in the EC2 instances, bring up the services, you only take care of putting the networking connectivity between the nodes. Pretty much you take care of everything. You just give me the Kubernetes once it is available. I'll just use the Kubernetes. I'll start running my application and I'll just make use of this. That's it. That is called as a managed Kubernetes cluster, guys. So if this is a managed Kubernetes cluster, is mean that the not only the servers, as of today you are getting the EC2 instances from AWS, right? Not only the servers, you are getting the whole Kubernetes itself as a service model. So you don't need to create EC2 instances manually. You don't need to install the Kubernetes packages manually. You don't need to bring up the services. You don't need to set up any of the networking related things. Nothing. Just say that, hey, I need a Kubernetes cluster. The AWS will do everything for you. They will give you the Kubernetes cluster. You just take it and start running the application over there. Isn't it cool? So that the administrative effort that you need to put in order to maintain a Kubernetes cluster from scratch, all that will be now gone away, and that is now taken care by your service provider itself. That is what is the managed Kubernetes cluster. When the cloud service providers are providing the managed Kubernetes cluster for you, what is your take on guys now? There are two options, right? Option one, you only go and create a EC2 instances by yourself. You log into each and every server, install the softwares, bring up the softwares, right? I mean to say bring up the services, do everything pin by pin, all the steps. That's one option. The second option, you take the Kubernetes cluster, which is predefined, pre-installed, pre-set up for you by the AWS, and just run your application there. That's the second option. Which one do you feel better in terms of using it in the real time, right? So definitely, right, 90% definitely the people will be preferring the managed Kubernetes cluster if at all you are on a cloud infrastructure. If you are not on a cloud, if you are using the servers on premises, let's say, then obviously you don't have any choice, right? You need to install the Kubernetes softwares by yourself on your servers because you are using the on-prem servers. But if you are using the cloud servers, then why should you be struggling to set up everything by yourself? Let AWS will do it for you. Take the cluster, run your application. So simple. So that the administrative effect is less, maintenance is less. You don't need to worry about any of the infra component, right? Just run it as it is. AWS will take care of everything, guys. That is called as a managed Kubernetes cluster, right? Now, so when I say a managed Kubernetes services, right, the Amazon is offering the managed Kubernetes cluster as a EKS product, which is a Elastic Kubernetes service product. The let's say if you are using the Azure cloud, then the Azure cloud is offering the EKS cluster. The IBM is having their own Kubernetes managed Kubernetes services. Google Cloud has their own managed Kubernetes services like a GKE. So these are the different managed clusters from the different cloud platforms that are available right in the market. Based on which cloud that you are using, you can go and adopt or opt for the specific managed service that you would like to. Definitely, since we are discussing about AWS Cloud and we will be leaning towards the EKS, which is the Elastic Kubernetes Service, which is a managed Kubernetes service, which AWS take care of preparing everything for you and give it. So what are the advantages if you go with the managed services? As I said, right, the first thing is the pay as you go service. That means, right, definitely the billing perspective, the managed clusters will be less because we can opt for the pay as you go service. How much load that you are paying, sorry, how many services that you are running, how much compute that it would need, automatically, right, you need to pay for the same. You don't need to go and upfront take the whole bunch of EC2 instances and pay more, right? So the pay as you go service is possible if you are using the managed Kubernetes services. And obviously, it's very easy to do the application deployments because we don't need to worry any of the Kubernetes maintenance, right? And as I said, the operational overhead will be eliminated, right? Let's say for any reason, if one of the server gets down, let AWS will take care of to bring it back and give it for you, right? We don't need to worry about how to recover the instances. I mean to say, if any one of the worker node is down, the AWS will now take care of how to bring back the worker node to running. You don't need to worry about that failure. So like that, anything at a infra level of failures that will be taken care by the AWS itself if you are using the managed services. So far so good. Then what is the case, right? If I am not using the cloud, let's say I'm using the on-premises infrastructure, then what will be the other options are there in order to set up the cluster, right? So Setting up the Kubernetes cluster has different ways, the different methods. Here I'm calling some top 10 different ways how you can use the Kubernetes cluster, but it could be a few more as well, guys. Everyone is now started off their own way how the Kubernetes cluster can be deployed by doing some kind of a customization. As the Kubernetes is the open source project, you don't need to pay a license for the Kubernetes software alone. So it is an open source project. Everyone can do their own wrapper on top of it and can do the customization as per their own and can release it as a different product too, right? So if you see the list here, right, Minikube is one of the method where you can install and deploy the Kubernetes cluster. Minikube is all about setting up the control plane and the worker node both together in the single system, right? If you set up the cluster, sorry, if you set up the control plane and the worker node, both components in one single system, that is called as a Minikube. kubeadm is one of the popular Kubernetes installation method. This method will be more convenience if you are using the on-premises infrastructure, right? To set up the cluster from very scratch by yourself by running all the commands, steps, installation, packages, whatnot, right? Everything you need to do step by step by yourself, right? That is where the kubeadm command will be there, right? And if you are using the on-premises servers, maybe the kubeadm is the best method to set up the clusters, right? And COPS is the another method. The COPS is again one of the popular uh, Kubernetes installation method, right? Which will be more for the AWS. Let's say in AWS, I don't want to use the managed, but I want to create a EC2 instances and set up the cluster myself. Then the COPS is one of the method that will give you some flexibility how you can install and set up the Kubernetes cluster. Now, if you go for the managed one, then yes, EKS is the managed Kubernetes cluster at a AWS side. The EKS itself is offering at least 3 different type of Kubernetes clusters. It's all Kubernetes only, but the kind of the infrastructure abstraction that the AWS is giving, right, will be vary. The EKS EC2, right? EKS EC2 in the sense the AWS will take care of, sorry, the AWS EKS EC2 in the sense you will be getting the EC2 instances to run the Kubernetes cluster, right? But the question here is who will manage the EC2 instances, right? If you manage the EC2 instances, then that is called as a EKS EC2 unmanaged instances or unmanaged cluster. If AWS is managing the EC2 instances, then that is called as a AWS EKS EC2 managed cluster. That's how there are 2 different types, guys. So what exactly difference between managed and unmanaged? Managed in the sense, let's say, right? Let's say if your EC2 instance is got terminated for some reason, right? Then AWS is now responsible to replace the node and fix the issues and make it healthy again. If this is a unmanaged, right? And of course the patching as well as I see in a chat window, right? So patching in the sense upgrading the packages, installing the packages, or setting up it, make it up to date to the current trend, whatever it is, right? So everything the AWS will take care of. If it is unmanaged, then the EC2 instances you need to take care of. Of course, like installing the packages, doing all this cluster setup is still a EKS only, still managed only, but the EC2 instances are not managed by AWS. That is something that you need to take care of if you feel you need to do a lot of customization as per the requirements. The EKS of Fargate is the another Kubernetes cluster. The Fargate in the sense there will be no EC2 instances, guys, right? There will be no EC2 instances. EKS Fargate is a serverless architecture. There will be no servers. Of course, there will be servers behind the screen at the AWS side, but at least from your side, you don't see any servers. You don't need to see any servers there. Getting me? Right? So the AWS will take care of creating a servers, managing the servers, everything completely 100% transparent, which you cannot see the servers. You don't need to see the servers, right? You just create a EKS Fargate cluster, just deploy your application, it will run. The advantage here is it's kind of a lambda, okay? So if this is a lambda, right, whenever your application is being run and how much compute is being utilized, you need to pay only for that, right? You don't need to pay anything extra. So that's how it is called as a serverless architecture and pay as you go service model. So if this is a EKS Fargate, then you just run your application, right? How much compute that the application would need, and you just need to pay for that only. You don't need to pay anything extra. You don't need to reserve any capacity because you are not creating any EC2 instances as such. RKE is the another Kubernetes engine, which will be the product of the Rancher. There is a another product called Rancher. The Rancher has their own Kubernetes engine. It's again, as I said, right? It's a Kubernetes only. Since the Kubernetes is the open source, right? Everyone can take that Kubernetes and can build their own wrapper out of it. And we can see a Red Hat OpenShift Kubernetes engine as well. Again, on top of the Kubernetes, the Red Hat is putting their own OpenShift layer by adding some other benefits, features, right? That's how they are making their own thing. AKS is the Azure one and GKE is the Google one. So basically, in the real time, what kind of the infrastructure that they are using, in which cloud they are, or in on-premises, right? Based on that, the people will decide which type of the Kubernetes will be more optimal, and they will be, using the things accordingly. But more or less, whatever the method that you use, only the installation steps, configuration step, and I mean to say, initially to set up the cluster, right? That will be vary. That process will vary. But once the cluster is completely ready, then there will be absolutely no difference, right, in terms of deploying the application, running the application, and accessing the application. That means all these different methods are making some flexibility for you to minimize the complexity to install and run the Kubernetes cluster. Getting me? Because setting up the Kubernetes cluster is very complex activity, right? That's the reason everyone is putting their own effort to make the things minimized. Rather running 10 steps, maybe it will help you to run only 4 steps. That's how everyone is preparing their own installation methods, and that will give you some flexibility to install. But once it is installed, once it is set up, it's just a Kubernetes, no difference absolutely, right? That means whether the Kubernetes is running in a GKE or in a AKS or in a RKE or in a EKS, or it is in a OpenShift or it is in a on-premises, either the way, right? It is absolutely the same, absolutely same commands, and no difference, guys. Right? Only the installation method will vary based on the type of the infrastructure that you are using, and the billing aspects, few other things will be get vary, right? And as the Kubernetes is the orchestration engine, right? And I called out already that, right, the Apache Mesh OS and Docker Swarm are the two alternatives for the Kubernetes, which were, which will be working as a orchestration engines only. But the Kubernetes has their own good weightage, and hence we are choosing Kubernetes to as a orchestration tool for us application deployments. Out of all these, right, definitely we will be preferring the EKS since we are on AWS. In the EKS, again, AWS EKS EC2 managed instances. That is the preferred one, which will be giving the less maintenance, less effort from the engineer perspective, because AWS is going to take care of right lot of stuff to give you the servers. Then we can just go ahead and start running the application on top of this. Good with that? As I said, right, the kubeadm or KOPS kops, that is just name of the installation method, how you can set up the installation or how you can set up the Kubernetes cluster, right? Nothing much. That is the installation methods, okay, or in the installation types that the people are offering. So if I go to one of the article in the devopsrealtime.com, here I just have called out the different methods that will be helping us to install the Kubernetes clusters by yourself. The kops is the one method which will help you to follow some steps here to install the cluster. EKS CTL is the other method to deploy the cluster. kubeadm is the another method to deploy the cluster. These are the specific steps that we need to follow. Right? Let's say if you want to use the kops method, kops is the installation method, the type, right? So then you see these are the different commands. These are the steps that we need to follow one by one, one by one. We need to run all these commands in a sequence. Finally, the cluster will be ready, right? Like that, the steps will be vary based on the type that you are choosing. Are you choosing kops method? Are you choosing kubeadm method or any other, right? That's how it works. But when you use a managed, then you don't need to use any of this. Just tell to AWS that, hey, can you please create a cluster for me? They'll give it for you. You just use it and start deploying the stuff. Getting me? Now, definitely we are not using any of these installation methods in the real time, right? Since we are leaning towards the managed clusters. Until unless you are on on-premises infrastructure, then definitely you need to set it up from scratch. But definitely if you are on cloud, for sure you will be using a EKS only. I think I have given the answer right. So if you are on cloud, go with the managed. If you are not on a cloud, definitely you need to use the kubeadm, which is the way to install and set it up on the on-premises infrastructure. Again, only the installation steps will be vary, but more or less after that, the way how you use the Kubernetes will definitely be the same. So if I am using the EKS, because we have chosen that EKS is our preferred way of using the Kubernetes cluster, right? If we choose the EKS cluster, right? So then I need to inform to AWS that, hey, AWS, I need a EKS cluster. You need to tell that how many worker nodes that you are looking for, right? Then the AWS will take care of deploying the required worker nodes based on the number of worker nodes that you are looking for. Of course, right? Though AWS is setting it the things for you, you need to tell to AWS, right? Hey, this is what I'm looking for, correct? So if you say that, hey, I need a 3 worker nodes, the AWS will prepare everything for you, create a 3 worker nodes for you, install the packages over there, right? Everything, do it for you. Obviously, there will be a control plane, right? Which will be the master or a manager node, which will take care of the whole Kubernetes cluster related operational activities. And we already discussed that in the control plane node side, the API server service, and the scheduler, control manager, etcd database, right? And all of these different services will be installed and up and running. Of course, AWS will do all of this for us, right? And we have discussed that all the other supporting services are actually reporting to the API server service, and API server is the main service running in the control plane, which is responsible to talk to the worker nodes and get the things implemented, right? So, and there will be some services at a client side too. So whenever, let's say you wanted to deploy the application, right? My requirement is once the entire cluster is ready, right? Once the entire cluster is ready, all my goal is I have the Apache web server application that I wanted to run as a container and access the website from my browser. That is my requirement, right? So obviously you need to inform to the API server as a Kubernetes administrator by running the kubectl commands, right? Then using the kubectl, whatever the instruction that you given to the API server will take care of the rest of the part to make sure that your requirements are deployed and running it inside a container. And as we discussed, yes, the scheduler will be helping to decide your application should run on which worker node. etcd is helping to provide the metadata about the cluster, like the number of nodes, IPs, and other information. Once the application is deployed running inside a container, there should be someone to monitor it, right? I said the Kubernetes also provide the health checking capability to perform the health check of the application running in a container, right? If the health checks are failing, it will be taking the necessary action, all these things, right? How would it do that? So the control manager is the another service that is running in the control plane node side. The control manager is responsible for the actual health checking process, monitoring the cluster, taking the decision what needs to be done if something is failing there, right? And all of the other things. I would say like the control manager is all about the managing or operational kind of the activities will be taken care once the application is deployed. Good. Now, whenever you inform to API server that, hey, I have the image in my Docker Hub registry, could you please take that image and run that image as a container? That is my requirement, right? When you inform that information or instruction to the API server, and the API server will talk to the worker node, kubelet will receive the request, kubelet will go and inform to container runtime, hey, please create a container for this. It will go and create a container, right?
So, so who will download the, sorry to interrupt. So who will download the images? Is it the container runtime?
So technically, right, in this overall flow, right, if you look through, who is responsible guy here to download a image from Docker Hub registry and creating a container out of it? It's the responsibility of a container runtime only, obviously. It's not a API server is doing, right? It's a container runtime that is the guy responsible to create a container, and that is the guy responsible to pull a image as well. Of course, but since we are not working with the containers directly, I mean to say we are not directly interacting with the container runtime, right? We are not working with the container runtime now. We are working at a API server level. We are working at a Kubernetes level. All what I'm doing is I will just inform to the Kubernetes API server, hey, this is the image that I wanted to run as a container. Let the API server handle everything behind the screen. Yes, from technically, container runtime is the one who is pulling the image and creating a container. But do I need to worry about it? Who is actually creating a who is creating a container? Who is pulling the image from the container? From the Docker Hub? Not really. I don't care about that. Who is doing all of this? I will just inform to API server, hey API server, you take care of whatever is needed to make the things happen and run the application, correct? So if at all for any reason, if the image pulling process, if the image has to be pulled from the registry, right? If that require any username and password, let's say, usually if the registry is a private registry, it need a credentials, right, to download the images. If at all it needed a credentials, you supply the credentials, right? When you are running the kubectl, you only supply the credentials to the API server. Hey API server, this is the image available in so and so registry. These are the credentials to download the image. Could you please run it as a container? You supply all the required information to the API server. The API server will handle everything. If at all it needed the credentials to download the image, the API server will pass all the relevant information to the container runtime. The runtime will use that information and will be doing the necessary stuff for you. Are we good with this? Hence the reason we are not really worrying about the container runtime. Whatever is needed, you just inform to API server, let API server handle everything behind the screen. So at high level, I would say yes, the Kubernetes is the guy who is taking care of pulling the images, running the containers, managing the containers, everything. That's the high level term that I can use. But if you go deeper and deeper, when I say Kubernetes, Kubernetes has multiple services. Each service has their own responsibility. And the container runtime is the one who is doing the actual job. The API server is informing to them. This is all the architectural perspective. Now, you should be understanding the word called abstraction. The abstraction in the sense, right, someone is putting some layer on top of the existing, and they will be making the things more easier and easier. That's called as a abstraction layers, right? So here, whenever the API server is instructing to the kubelet that this is the image that I wanted to run as a container, then finally the container runtime will do it for you. So the container is running. But the Kubernetes is not only responsible for running the container, it is also responsible for doing the health checking. It is responsible for providing the networking connectivity between the applications running in the different worker nodes, giving the external access to the application from outside world. There are many, right? So to handle all of these, right, it has to work with the application, or it has to work with the control with the container. But do you think who is the owner of the container, guys? If I ask you a question, who is the owner of a container? It is a container runtime, right? Because container runtime is the one who is responsible for creating a container, managing the container, everything. So I would say container runtime is the actual owner for for your container. But how would the Kubernetes software can go and manage the container for you, right? How it can go and monitor the container, look for the health checks, do all of these best practices, right? So technically it's not feasible. So that's the reason when the developers has developed this Kubernetes product, right, that time on top of this container they have created a one more abstracted layer that is called as a pod. So pod is the abstracted layer that is created on top of the container, so that all the container properties will now become the pod properties, right? So whatever is happening inside a container, all those properties, all those characteristics will now be get exported, will be assigned to a pod, which is another abstracted layer that is created on top of the container. So I would say the container is equal to pod, right? Just for understanding, the container now onwards, the container is equal to pod. Both are same. Container is the term that we are using, which is specific to the container runtime perspective. Pod is the term that we are using from the Kubernetes perspective. Why it has to create a pod abstracted layer? Because that's the flexibility how the Kubernetes can manage your containers. Being said that, since I am working at a Kubernetes level, I'm not working at a container level, right? I'm not working with the container runtimes directly, right? I'm working with my Kubernetes. So now my terminology is like this. Whenever I wanted to deploy and run my application, when I'm informing to the API server, I will inform to API server that, hey API server, could you please deploy my application to run as a pod? You see, I'm changing my terms now. Previously, I was saying that run my application as a container, right? Now I'm not using that container terminology. What I use, could you please go and deploy my application and run as a pod? Because pod is a term that we need to use at a Kubernetes level. When I say pod, again, inside the pod, it is a container only, obviously, but we are using the pod terminology, which is specific to the Kubernetes, because the Kubernetes has their own technical manner how it can operate the containers using the pod abstracted layer. That is how the design is being done, right? That means you always be asking the API server that, hey, please create a pod. It will go and create a pod. When I say creating a pod, inside the pod, it is actually creating a container for you. For now, you understand that the pod is equal to a container. Since I'm working at a Kubernetes layer, I'll use the term called pod. If I work with the container layer, maybe I'll use the term called container. That's just a difference of the terminologies, but think of like both are same. Right? So that means if you go a little deeper now, yes, the kubelet is the responsible guy to run your application, right? Right? The kubelet will inform to container runtime to create a container. Before that, yes, the kubelet will create a pod, right? The kubelet will try to create a pod wrapper. Then it will inform to container runtime. The container runtime will be creating a container that will go inside a pod. Pod is one upper layer. Inside the pod, container is one layer. Inside the container, your application is there. That's how the different layers that we need to understand. In this overall context, I will not be using or I will not be storing the images anywhere. I don't need to worry about the image here first of all. Do I need to worry about the container image? Of course, using the image only, the containers are created, but the image is downloaded from the registry and that image will be extracted and created as a container. That's it. Why should I be worried about the image here? Because I see a chart that says that, right, the pod is same as the image, right? No, pod is not an image, right? Pod is the abstracted layer. That's the term that we use in the sense the container name will become the pod name, container IP will become the pod IP, the container status now will become the pod status. If the container is running, pod is running, container is crashed, pod is crashed. The container network will now become the pod network. Getting me, guys? If the container is stopped, pod is stopped, something like this. So that means whatever the operations that you are doing with the container so far in the Docker concept that we talked about before, all those operations now I'm trying to play around with the pod. I create a pod, I stop the pod, I restart the pod, I terminate a pod. Getting me, guys? When you create a pod, it creates a container inside it. When you stop the pod, it stops the container inside it. When you restart the pod, it restarts the container inside it. Getting me at least now? So the pod is the layer that is created by the Kubernetes just to make some things flexible from the technical perspective so that Kubernetes feels easy to manage the containers using this pod layer. So we will be always working with the pod that in turn take care of running the containers for you. Yes. So that means pod is the way how the Kubernetes is managing and operating the containers, I would say. You don't need to see any advantages or disadvantages with I mean to say you don't need to worry about what is the advantage with pod. Why can't I work with the containers directly? Don't look at from our side. From Kubernetes side, from the technical perspective, right, the Kubernetes can make use of the container, can monitor the container, can manage the containers efficiently only if it having a pod wrapper out of it, something like this. Then only all the Kubernetes capabilities that I'm going to get, right, can be get applied, can be get things done. Let's say tomorrow I would like to have a auto scalability, I would like to have a load balancing, I would like to have few other best practices, right? The Kubernetes cannot apply all these best practices directly to the container without having a pod. That's the reason the pod wrapper is created for you so that using the pod concept, you are going to apply all these best practices. That is how the Kubernetes design itself is there. And I see one more proper statement in the chart. Yes. So it is going to create a pod, then it is going to inform to a container runtime, hey, now you please create a container within my pod. Then the containers will be created. If the container gets up and running, then those container properties will be collected, will be kept as a pod properties, and then the Kubernetes will always try to monitor the pod or will try to use the pod information to see what's happening there, something like this. Now, so the next step is maybe I would like to give you one more statement, right? So now onwards, wherever I was using the container terminology before, right? Maybe from now onwards, I'll use the pod terminology. Is that good? Maybe I will say that, hey, I have the image in my registry. This image I wanted to deploy as a pod, right? Previously, I was saying that I wanted to deploy as a container, right? Now I'll say that I wanted to deploy this as a pod. In the sense, it takes care of container behind the screen for us, which I don't need to worry about it. I always worry about the Kubernetes layer now. The Kubernetes will take care of the low level containers automatically for you. We'll see the cloud control manager component later because I need to have some use case. So if you see here, every container has the pod is created as a abstracted layer out of it, and that's how the Kubernetes can get the flexibility to manage it. You will know more advantages why the pod is created, right, today itself after some time. Now this is called as a EKS, guys.
Yeah, Pierre, I have a question.
Yes.
So let's say there is a 3-tier application. Okay. So let's say there is a Redis database or a MongoDB database, DBT web service or something, and there is a middleware, some application. So in that case, should we have 3 pods? One pod depicting for a database application and one pod for the HTTPD or Nginx.
Thanks for the question. Okay, and I'll take up your question bit later time. Okay, and definitely that is part of our agenda, right? And few others may get confused with the terminology called Redis and other stuff, middleware. Whoever is completely new, I always try to go in a sequential upgradation of delivering the terminologies, right? So I think
Sure,
it
sure,
it
sure.
takes another 2 days time at least to go to that level, because there's still a lot of basics that we need to go through to get into that level. Okay. Yes, definitely we are going to deploy the 3-tier architecture as well as part of our series. Now, this is what I'm trying to focus now. A question for you at this time again. When I say control plane, and of course the control plane is more important for me because that is the one who is taking care of the entire cluster related operations. Could be deploying the application, running the application, monitoring it, whatever it is, right? But tell me guys, from your perspective, what is that important for you? Do you care about the scheduler, control manager, or etcd, or control other things? No, right? All what you need to care about is the API server, right? And of course, it's a pod. I mean to say, from the Kubernetes administrator perspective, how are you going to connect and inform the instructions to your Kubernetes cluster? It's the API server, right? From this particular flow. That means you are actually running the kubectl command. You will definitely see how the commands will be get executed. But before I go to that level, we need to understand this flow, right? When you are running the kubectl command, the command line will go on connected to API server. That means I just need to worry about the API server service, and the API server has to be connected to my kubectl, correct? If the API server is connected for my kubectl command wherever I'm running the command, then that's good. You just give the instruction to the API server, let API server will take care of whatever is needed for you behind the screen, and let the application is deployed and running it as a pod, right? Hence the reason. And of course, when I say, when you ask me a question that can we access the control plane, in the control plane, what is that you wanted to access, guys? You, in the sense, as a Kubernetes administrator, as an engineer, what is that you wanted to access in the control plane? That is what I'm trying to, right? You just need to have an access to the API server. If you get a API server access, that's it. You don't need to worry about the scheduler and other things. Those are there internally. API server will handle for you, right? Why I need to access the API server? Because then only you can inform to API server what is your expectation, what is that you are looking for, right? Let's say how the image in my registry, this image has to be get deployed. How will you tell to Kubernetes? You need to inform to the API server only by running the kubectl commands. Being said that, what AWS is saying that, right? The AWS says, hey, this is a managed Kubernetes cluster. That means the AWS is managing most of the stuff for you, right? So AWS says that the control plane at least is a fully managed service for you. That means the easy to instance where the control plane is installed and set up, that EC2 instance will completely invisible for you. You will never see the control plane EC2 server on your EC2 dashboard. You can see the worker nodes, like if you are having 3 worker nodes, right? You can see 3 EC2 instances running in your account. That is fine. But the control plane EC2 server, right? The control plane EC2 server will not be visible for you. You cannot see the control plane EC2 server. You cannot logging into the control plane EC2 server, and you don't need to worry about it as well. That's what it is called as a managed, right? So the AWS will take care of deploying the control plane EC2 server, installing the required softwares there, and AWS will tell you that, hey, this is the API server information that you need to use to connect, right? You run the kubectl command, you connect it to the API server, whatever the AWS has set for you, and just inform your instructions. You don't need to worry about how the API server is running, where it is running, right? In which EC2 server it is running, how the control plane is set up. If the control plane EC2 server gets terminated, how that is being, you know, recovered as a high availability concept. No, you will never worry about any of these things related to the control plane. Let AWS handle. Yesterday you were asking me a question that, can we have the high availability for a control node? Can we have two control nodes? You can, but when it comes to the managed Kubernetes, right, like a EKS, you will never worry about the control plane at all. Let AWS handle everything behind the screen. You just only worry about your worker nodes and inform to API server by connecting, and right, give the details. Let that will take care of backend for you to deploy and run the applications in your worker nodes. Are we good with this? Now, even for unmanaged, right? Either it is a managed, sorry, either it is a EKS EC2 unmanaged, or it is a EKS EC2 managed, whatever the mode, the control plane is completely taken care by the AWS for you. You are not worrying about the control plane at all. So you just connect it to the API server, give your instruction, let that is handling to manage the whole deployment process. That is the reason why I'm not worrying about the high availability of the control plane node. I will only worry about the high availability of my worker node and how I can run my business application over there. Let API server is, you completely forget about the API server, how it is being running there if you are using the EKS. And you don't need to see the etcd database. You don't need to do any of these. If you want, yes, you can do, but you don't need to worry about anything related to the control plane. Let the AWS will be handling that. We are spending 2 days just to understand the Kubernetes architecture, right? Now, let's say I wanted to deploy the EKS cluster. Now tell me guys, EKS and Kubernetes both are same or not? We'll get a better clarity once we go for the implementation, but at least for now, EKS and Kubernetes both are same. Okay, so I see a answer as yes. Okay, so my answer is no. Okay, EKS, Kubernetes both are not same. Maybe you will know the reason down the line. Well, I wanted to deploy my Kubernetes cluster as a EKS. Okay, I wanted to deploy the Kubernetes cluster as a EKS service. Let's say I'm taking some worker nodes. Maybe I'm taking 4 worker nodes with me, right? Now I have the API server. You see the difference, guys. Now I'm not going through the terminology called control plane. Why? I don't worry about the control plane now. Of course it is there, but since AWS is handling behind the screen, why should I be worry about that? I will just go ahead with the API server. Is that good? Right? I have the API server that is currently running. The Kubernetes administrator running the command to interact with the API server and give the instruction, hey, this is the image I want to run as a application. Now the API server will take care of running your application inside your worker node. Mostly the scheduler service will take care of which one will be the best pick out of 4. Definitely your application will be get deployed it into any one of the any one of the EC2 instance or any one of the worker node. When you have multiple worker nodes with you, it is possible to group the worker nodes as a node group concept. What is node group? Node group is just a logical grouping. Node group concept says that it is just a logical grouping concept where you can group the number of EC2 instances or number of worker nodes together and give a name for that. Let's say the first 2 EC2 instances, the first 2 worker nodes I am putting into a group, that group name called web1. Let's say the second set of 2 worker nodes I am putting it into a group, that group name called web2. Like that we can create a node groups where you can keep the multiple worker nodes inside a node group and just give the name whatever you wanted to. When I say a Kubernetes cluster, the Kubernetes cluster terminology is the whole concept, right? The all the worker nodes along with the control plane, everything is called as a cluster. The node group is not called as a cluster because that makes a conflict from the terminology wise, because we already having a concept called Kubernetes cluster. Now we should not call the node group as a cluster. That will make the conflict. First of all, why I need to do the node grouping like this? Why I need to logically group the number of EC2 servers like this? Let's say I have 2 websites, okay? I have 2 websites that I wanted to run, website 1 and website 2. The website 1 is running with the so and so image. The website 2 is running with so and so image. Are we good with this? Right? We can create one image that is running for one website, the another image with a different set of code that is for another website, possible, right? Usually when you inform to API server that, hey API server, this is my image, please run it. It can go and run the application everywhere, wherever it wanted to, right? By default. I have 4 servers with me. Your application can go and run, right, anywhere in the 4 servers based on the scheduler policy, or the scheduler will decide, but it can go anywhere. Sometimes, I wanted to control my application should go to which worker nodes. Getting me? Whenever you wanted to control, you don't want to give the decision choice to the API server to take a choice of the worker node placement. You need to control by yourself. Hey API server, I want to run my application, but please do ensure this application is deployed into a specific few EC2 instances only, not everywhere. If you are looking for that kind of the granularity in terms of the scheduling, you can go with the node group concept, so that when you are running the kubectl command, right, that time only you can tell to API server, hey, this is the image I want to run as application, but please ensure this is being running on the worker nodes that are grouped as a web1 or grouped as a web2. That is how you can inform the node group label, right, to the API server how and where you are expecting the application to be running. Are we good with this? That way you can tell to API server that the web1, please run it in the web1 node group. It will go and run on those 2 EC2 servers only. It will not go to the other servers. If you say, hey, this is the web2 image, please run it on web2 node group only. When you say that instruction, it will try to run the application on that particular nodes only, not in other nodes. Why do I need to control all of these guys? Of course, this is happening through the node labeling only. We are labeling the each node, which is now called as a node group. But what is the purpose of doing this? Let's say as an example, the website one is very lightweighted application. Let's say only 10 people are using my web one. Okay, only 10 people are using my website one. Okay, but the website 2 is very much dynamic website. Almost no, the thousands of people are accessing my website 2 as an example. Then obviously the website 1, I wanted to run it into a minimal server, right? Maybe one processor, 1 GB RAM is fine for me, where I wanted to run the application because, right, my website is less number of people are accessing. But the second website is very huge one, thousands of people are accessing. It may need more capacity, more right things. In that situation, you can control these things. In the web1 node group, maybe I'll go with the t2.micro EC2 servers. In the web2 node groups, maybe I'll go with the larger M5 series instance type. That way I can manage the computing capacity, how we are expecting to be on the each node group. Are we good with this? Because when you get into the real time, right, in the real time, it's not about one single website. They have a lot of applications, a lot of websites, a lot of use cases, right? They don't want everything to be mixing up and running it in everywhere they want it, everywhere on the nodes, right? No, we should have some granularity or some customization. For the reason, we can do a node group concept and logically group your servers so that you have the control to deploy the server applications there. Now the first thing is auto scaling, right? I'm keep saying that the auto scaling is the one which we are looking for here. So at the moment, let's not talk about the auto scaling of the application running as a container or as a pod, but let me talk from the worker node perspective. Let's say if one worker node is down, automatically my worker node has to be recovered and spin up. Is that called as a high availability at a worker node level, or high availability, or kind of? Yes. Let's say in the web1 node group, currently there are 2 worker nodes. Okay, that means there are 2 EC2 servers. You now running the web1 application, it is currently running as a container or as a pod in the web1 2 worker nodes. Let's say these 2 worker nodes are not enough to serve the application. It need more capacity. What is the solution, guys? That means the worker node itself is not sufficient to serve the compute. I need to create one more worker node, right? In the sense, the worker nodes that you are going to create here, you go and keep those worker nodes inside a auto scaling group. This is the AWS auto scaling group concept only. We are mixing the things here now slowly, guys. I'm mixing the Kubernetes concept with the AWS concept. Kubernetes is different, AWS is different, I agree. Kubernetes is all about the orchestration software that will take care of how effectively a containers can be running. But AWS is different, right? It's all about the infrastructure related component. I'm mixing the both things together now.
But
So what I
how
do,
can we,
go ahead, please.
sorry. So how can we ensure that, let's say, an EC2 instance which is spinning up, let's say an EC2 instance is equivalent to a worker node, right? So when a EC2 instance spins up, whether it will be a part of node group web 1 or node group web 2, is it through some launch
We'll do that.
template or?
We'll do that as part of the deployment, right? So I'm going to deploy the cluster just now after 10 minutes. Once this is done, we'll see
Okay.
how are we going to do the configuration per se, right?
Okay.
But definitely, I'm going to take the help of AWS autoscaling group concept. I will define minimum, maximum, all the autoscaling features. It will take care of creating the instances, which are now called as a worker nodes, right? And that autoscaling group servers, I'm again putting a one more logical group called as a node group. Why do so? Autoscaling group is the group that is at a AWS site to manage the worker nodes from the scalability perspective. Node group is the logical group that I'm again putting that is at a Kubernetes side to take care of, right, or identifying the servers to deploy the application whenever you have been specifically looking for. Getting me? Because you should not get confused between the autoscaling group and the node group. Autoscaling group is the infrastructure level group which the AWS is handling to create a servers and scale the servers when needed. Node group is the Kubernetes concept which will be taking care of right the application deployment it into that specific servers whenever you have been asked for. Now, based on the requirement, it can go and start deploying wherever it can be. We'll get to know few of the puzzles that you have once we get into the implementation, guys. The reason why I'm spending some time in going through all this bunch of architectural discussion, right? Those things I cannot postpone it further because the time when I'm going to deploy the EKS cluster, all these concepts should be fairly with us. Now let me deploy the cluster. A question for you now again. How I can deploy a EKS cluster? How can I go and create a EKS cluster, guys? What do you feel? Which one is the better way to deploy the EKS cluster? The AWS UI or the AWS console or a Terraform? Getting me? The reason why I'm asking the question, right? So if you go to the AWS, in the AWS, you search for the EKS. EKS, Elastic Kubernetes Service, is the one of the AWS service. And we know that all the AWS services and the resources can be deployed using Terraform, right? So it's very difficult to deploy the EKS from the console also. If you try to, still it will be difficult, guys. Let's say you go to the EKS and just click on add cluster, right? There are multiple steps are there. It's very difficult to go through this process and set up the cluster, guys, because we need to take care of auto scaling groups, IAM roles, cluster, node groups, a lot of things are there. So it's flexible to deploy the cluster using the Terraform. Let me do that now. Sorry, guys. So I have the Terraform code already written for the EKS deployment. I think I don't need to go through how to create a code, how to write a code for deploying the EKS. I think I don't need to write because that is just part of the Terraform documentation. AWS EKS a Terraform resource, right? So it's just matter of going to the Terraform documentation and getting the resource type AWS EKS cluster and just follow the documentation and get the basic syntax and just fill up the options, right? So easy. So since we are already familiar about this process, let me go and get the Terraform code, which I have prepared it already, and I'll use that. I'll share this code with you guys as well. For now, I have the code in my Bitbucket. I'm going to download that code. So this is the command that I need to use to download the code. I got the code here. So I think let me come back to this one more time. Now, how much AWS will be charging for the EKS, guys? In general, AWS is going to charge for what? AWS is charging for the processor, memory, storage, network, data transfer, right? Pretty much these are the things. That means when you deploy the EKS, the AWS is charging for your EC2 instances only, nothing much. How many servers that you are running in, they will just charge for the same. They are not charging anything extra just for the EKS per se. Maybe the control plane is the one because they are running something behind the screen, but in general, they are not taking anything extra. How much compute that you are consuming, you are just paying for the same, guys. Sorry. Well, I have the code here available. I will definitely walk through this code at a high level. So I'm just actually creating a dedicated VPC for me. And here you can see I'm actually creating the VPC where I wanted to deploy my EKS cluster and the respect to internet gateway. And I'm just creating the subnets, right? The public subnets and the private subnets, right? And I'm just creating the required security groups, and I'm creating the IAM role. You just need two IAM roles, one IAM role for your control plane server and one IAM role for your worker nodes. So there are two IAM roles, right? And what and all permissions has to be given for these IAM roles? All this will be as per the AWS documentation. So we just need to give the permissions based on the stuff, right? But since this is a very standard static for every operation, the people will just take this copy paste and use it. We don't need to worry too much about what kind of the permission that I wanted, because this is not going to be changed from project to project mostly, right? It is pretty much standard. So I just created two IAM roles here, and this is the provider block. This is the output block to give you the API server URL, which I'm looking for. Correct. At the end of the day, once the EKS is ready, what is that I need is the uh, the API server, right? So I'm just printing the EKS endpoint, which is the API server, and in the EKS.tf, I'm just putting the AWS EKS cluster resource type, and I'm just giving the details how I'm expecting the EKS cluster to be, the EKS cluster name, and which Kubernetes version or which Kubernetes software version that you are looking for. The Kubernetes is just a orchestration software, right? The Kubernetes is having the different versions, right? So 1.29 is the latest version, and you can see 1.28, 27, 26, all these things. So whichever the version that you are looking for can go and specify it over there. So this version of Kubernetes software will be get configured on your EKS. In general, in real time, right, the companies will be following the latest release by going through this end of life timeline. You see this? That means what? If the people are using 1.28, let's say, they will be using this version until 2024 October only. After that, they will not use this because that is the end of life. Again, they have to go for the new release. That's how they follow the end of life, and they will be keep on upgrading the versions as well. But for now, let me go and take a 1.28 version, which is at least one level below. So you just specify the version here, which version of EKS, sorry, which version of Kubernetes that you are going to get, and the role that you need to, and the VPC that it has to deploy, and that's it. Now you see the node group section here. This is where I'm going to set up the node groups, and you see here I'm telling that this is the node group name. Probably web1 is my node group name. In this node group, I'm looking for the instances, the worker nodes to be deployed, the worker nodes, the root volume to be a 20 GB, the worker nodes to be T3.medium type. It should be get created with so and so EC2 key pair, to be with so and so security groups. I'm reviewing some stuff, guys. We'll talk about that later. The worker nodes to be get deployed it into which subnets, and you see this section. This is where I'm telling the auto scaling configuration, guys. Like what will be my minimum, maximum, and desired values of my auto scaling group, and that's it. And this is the second node group. Let's say web2, and you define what kind of the instances that you are looking for and other things, and the auto scaling capabilities. Each node group is basically maintaining its own auto scaling group to maintain the servers. A question for you at this time: if you look into my Terraform code, I'm telling that, hey, I need a T3.medium and I need this many number of servers. Am I specifying the AMI ID here? No. I'm not telling any AMI ID. I'm just telling that which instance type that I'm looking for and how many instances that I'm looking for. Let AWS take care of automatically to deploy the EC2 instances by taking the suitable AMI for 1.28 version that you have been chosen. That is called as a EKS EC2 managed instances. If you tell that, hey, this is the AMI that I wanted to, you might have been created the AMI by yourself, then you use your own AMI, the golden AMI, then that is called as a EKS EC2 unmanaged EC2 instances. So this is called as a managed instances because I'm not telling the AMI details. Let AWS figure it out what needs to be done. I'm just telling this is the type, this is the number of servers that I'm looking for. Are we good with that?
But in a managed thing, we should also not tell that how many we should record, the max, min, and desired, right? Depending on the load, it should increase. Depending on the load, it should decrease.
That is
Correct?
called as a
If it,
forget. Okay, that's the difference here. So if you are not telling the EC2 also how many that you are looking for, that is go as a forget. In the forget, you will never tell about the number of servers also. Let everything handle behind the screen. So managed, the terminology means that the AWS is going to manage preparing the infrastructure for you and giving it for you as a platform as a service model. But if you are expecting that, you don't need to give any EC2 servers also, right? It has to handle behind the screen everything. That will go as a serverless architecture. The terminology serverless will come into the picture if you don't see any EC2 instances, but still your applications are running in. Make sense?
yeah, yeah.
Of course, a lot of confusing terminologies. I'm trying to do the best to make the things happen.
We could have given spot instance also, right? In place of on demand.
Of
That will
course, it's
also
up
save
to
a lot
you.
of cost. Yeah.
It's up to you what kind of the instances that you wanted to. It will just take care of doing, just following your instructions here. Let me try to deploy this. Yes, we can do the spot instances, or you can choose whatever you wanted to, and AWS will just follow your instruction and will be setting up the servers for you. The managed terminology, the more, because of the control plane is something the AWS is handling. That is the main reason why we call it as a managed terminology here. No other reason. Sorry guys. Now you got to know the reason, right? So because when I'm running the Terraform apply command to deploy the EKS, by then you should all understand at least what is node group, what is EKS, right? And the auto scaling concept, all this. That's the reason why first I explained the architecture. Now you have at least some insight, right? At the time of me running the apply command here, or else it will be a black box. Agree with me? Node group is not a auto scaling template. Node group is just a logical grouping by just giving some tagging to the servers so that the API server can identify the server where it has to run the application. That is just identification label, nothing else.
For our CI/CD deployment, we use AMIs, right? In that case, it comes under unmanaged instances, right?
So there is no relation to the CI/CD and the AMI terminology. So in general, just to keep it very simple, because anyway, deploying the EKS cluster will take at least 15 to 20 minutes, guys. I just have executed a command. It takes another 15 minutes, I believe, minimum. Yes, coming back to the question, right? Managed EC2, unmanaged EC2. The only difference, the main difference is if you specify this is the AMI that I wanted to use, you might have been created your own AMI by yourself and you use your AMI, then that is a unmanaged, because AWS is not going to manage the server now because you are using your own AMI. If AWS itself is using the AMI behind the screen automatically for you, you are not telling the AMI, then that is a managed EC2.
I just wanted to know, is worker nodes, sorry, the node group is bunch of worker nodes, right? Is it, can I consider it in that way?
Yes, yes. Once the EKS is deployed, then I will show this EKS from the AWS console as well, how it look like. But believe me, creating this from the console is painful, because if you go to the UI, you need to create a VPC, security group, IAM role, EKS, node groups, auto scaling. Getting me, guys? Preparing all this from the console is painful task, right? Hence the reason I'm preferring the Terraform. It takes care of deploying everything for you because the code is already there. Node grouping concept is the Kubernetes concept, not a EKS concept, not a GKS concept, not a AKS concept. That is the Kubernetes concept, and that definitely will be there everywhere. Wherever you are using Kubernetes, the node group concept will be there, because that is a Kubernetes facility that it is providing to understand or identifying the node when it is trying to deploy the application. Now, while it is happening, anyway, it is still running, right? It takes some time. While it is happening, let me come back and understand the difference between EKS and Kubernetes. What is EKS and what is Kubernetes here? Because both are not same. When I refer it as a EKS, right, that is a component that is available at a AWS side. Let's say the AWS is offering the auto scaling group. AWS is offering the auto scaling group, and the control plane is managed by the AWS for you. The second point, the worker nodes are actually managed by the AWS for you automatically, because you are not specifying any AMI, right? By default, the AWS will take care of how to choose the AMI, how to provision it for you, right? So all those AWS layer components, right, are called as a EKS. Anything that is running inside the servers from the software perspective, like the API server, etcd, control manager, kubelet, this is what is the Kubernetes, right? So the orchestration engine software is actually the Kubernetes that is installed and setting up in your specific nodes. That's how we need to see the differences here. Let's say if I wanted to connect it to the EKS, I'll connect it to AWS. If I wanted to connect it to Kubernetes, I'll connect it to API server. Are we good with this? Of course, we can call it as Kubernetes is one of the subcomponent inside a EKS. Yes, we can treat like that. Probably now to give more questions, because my cluster is still getting deployed. I wanted to terminate one of the EC2 server. To whom I need to connect with? To whom I need to ask? I mean to say I need to work with the EKS, right? Not API server, right? API server will handle the software level components. API server will handle the software level component, the container or application orchestration perspective. Anything related to the worker node level, anything related to the AWS level, anything related to the infrastructure level will become the EKS layer. Anything related to the application high availability, application load balancing, how applications are running, how application is being monitored, how application is being deployed, how applications are connecting from one to other one. This is the Kubernetes concept. You'll get to know definitely once it is deployed, but since I got some time, I'm just trying to put something, and now I'm getting the error. Interesting. So it is complaining that the key pair that have been given there, that key pair is not found, and it is complaining. So what I do is I'll go back here and I will be modifying this to the key. This code might have been written very long back. This key pair might be not available in my account. So let me change that. Let me apply. Of course, right? So at least the AWS keys you should have been created already and kept it available in your AWS. Because no one will create a keys as part of Terraform. While it is happening, right? One other thing that I wanted to show, the subnets where the Kubernetes, sorry, the subnets where EKS is planning to create a EC2 instances, that subnets must be having a tag. The tag says that, you see the tag here, guys. If I go to one of the subnet, the subnet must be having a tag. The tag key name will be like this: kubernetes.io/cluster/ and your cluster name, and the value is shared. So this is the key value pair. This tag must be there for all the subnets that you are using in your cluster. This tag says that this subnet is now created for the EKS purpose or creating the EC2 instances purpose, because you may be having some 100 subnets in your account or in your VPC. How AWS know that which subnet is belonging into your specific cluster setup, right? So it basically identify that by using this uh, tagging concept, guys. I just wanted to give this heads up as well, so that this tag should match, and the tag, this is the name of the cluster that you have been given in the eks.conf configuration file. This name should match, or else it will not work. I'll definitely tell you where it will not work as well down the line when I'm trying to use of this concept, but yeah. Let me quickly go and do the things. Oh my God, I clear the screen. Let me apply one more time. I just wanted to run at least one application today. Okay, all what I wanted to show you is this endpoint. You see the https:// something. This is the API server, guys. I'm keep saying that the API server is the one which you need to connect, right? So this is the API server that you need to connect, right? You run the commands and connect it to this endpoint and give your information. It will take care of doing the whole stuff for you. Now, if you go back to your AWS and look for this EKS, you see that the EKS cluster is deployed with 1.28 version, and you can see more details about this EKS. If you go to EC2,
Why did you run the Terraform apply once more?
just because I wanted to show you this output that I'm collecting, or I'm printing this API server endpoint. This is the API server endpoint that you need to use to connect it to the API server to start giving the instruction how you are expecting the application to be get deployed. Because I ran the clear command that is gone, so I just wanted to show you that
Oh,
endpoint
okay,
how it
okay.
look like.
That's what I was wondering, that why it didn't come up in the first apply. Ideally, it should come in the first apply. Okay.
Yeah, because I ran the clear command that is gone, so I just ran it one more time. Now, if you see the list of servers, right, I'm getting 2 servers here. Why 2 servers, guys? If you look into the nodegroup.tf file here
Desired,
again,
desired, I think.
I have one node group. That node group says that minimum is 1, Of course, always it will go with the minimum number, right? And I got one server. In the second node group, again I have another auto scaling configuration that it says that the minimum is 1. So I have got two servers. One server is a part of Web2 node group. The other server is a part of Web1 node group. So I got two EC2 instances running as a worker nodes now. Can you see the control plane EC2? No, because that is fully transparent. Somewhere it is running behind the screen. You will not get to see that. If you go to the auto scaling group concept here, now you should be able to see the both auto scaling groups. One auto scaling group for web 1, the another auto scaling group for web 2. It is running with one instances at this time. You don't need to worry about all of this launch template, the how the launch template is prepared here, all this. Why it is a manager, right? AWS took care of creating a launch template. In the launch template, what will be the user data script, what will be the AMI, all that is well prepared for you automatically by the AWS itself. That is what it is called as a managed EC2 instances. And you see it is took care of using Swan image automatically for you. Yeah, that's what it is. Now I think my cluster is ready. It's just matter of connecting to that cluster and start running my application. I think let me go back to EKS one more time. When you go to your EKS here, and here also you can see the API server endpoint. It is the same. Sometime back I was showing in the Terraform, right? It's the same endpoint, and you can use this endpoint to connect with and just log in and access it. In order to connect to this endpoint, which is the HTTPS endpoint, you all should understand that this is the HTTPS. That means this is a secured endpoint. So we need to connect and authenticate to this endpoint by using the SSH keys, like a security keys. You all know, right? The public and private key combination will be there, which will be helping us to do the encryption, right? And the the private key will be at a client side, the public key will be at a server side. All this concept, right? It is following the same thing. So now we need a keys in order to connect to this endpoint and start interacting with that. How do I get the keys now? Who has created it? It actually created by the AWS for you, right? As part of setting up this whole cluster, correct? All the keys are actually created by the AWS for you, and somewhere you can see a certificate authority. So AWS has done something for you, and they have already set up the required keys, everything. Now, if I wanted to connect to this API server endpoint, I need to ask the AWS, hey, AWS, tell me now how I can connect to the API server endpoint. What will be the keys that I need to use, correct? In your command line, you just need to run the command called AWS EKS update hyphen kubeconfig hyphen hyphen name, specify the EKS cluster name and hyphen hyphen region, then specify the region in which region the cluster is currently deployed. If you run this command, you see this is the AWS command, guys. I'm sending this command to the EKS so that EKS will prepare the required keys, and the keys will be generated for you, which you need to use when you are trying to connect to the API server endpoint. How it's doing all of these? Because the access key, secret access key, right? AWS key is already there in my machine, right? That's the reason. Even the Terraform is using the access key, secret access key that are set up using AWS configure command, right? So it should be having the permissions. Now it's saying that, hey, it is updated the context, and the context is stored in so and so location. You see the location somewhere in the home directory under the .cube folder. There is a file called config. In that file, actually the context is saved. Let me see what is there in this file now. I'll just go to the desktop. Sorry, just go to C users, maybe user .cube folder config. This is the file, right? That is got created just now automatically. If I open the file in the notepad file just to see what is there inside, this file is automatically generated, and this file has the details about the API server endpoint that it has to use to connect with, and what is your EKS cluster ARN information. It has the details about the certificates. You see all these are the certificates. Somewhere you can see certificate authority, right? So it has the details about the certificate as well, and some other information. So this is the file that you would need to connect to the API server endpoint, guys. Without this file, you can't connect. This file is auto generated by running this command. Once this configuration is there with you, now the time to run the command called kubectl. Yes, these are the certificates for your API server endpoint. These are the certificates to connect to the Kubernetes API server. Now you use the kubectl command and talk to your Kubernetes. Kubectl get nodes. This is the command to see the list of current worker nodes on my Kubernetes cluster. Now you are getting the output. It's saying that, hey, the Kubernetes cluster has 2 worker nodes. How it is telling? The kubectl command that you are running, this command is now using the config file that is there in the default location to get the certificates. Then it is connecting to the API server. Then the API server is giving the response for you, because API server can get the details from the etcd database. It can give you the response. Now I can see that there are 2 worker nodes or 2 nodes in my cluster. To run this kubectl command, the kubectl command has to be installed in your machine, guys, or else how the command will work, right? So you need to install kubectl software. You can just go to the documentation and see the kubectl, and I wanted to install the kubectl on Linux, Mac or Windows. Choose whichever the one that flexible for you. Then follow the steps to install the kubectl. So you can see the commands, right? So you just need to follow these commands, which will be downloading and giving you the kubectl CLI. At the time of you are downloading the kubectl client command line software, it's very important to download the kubectl software which is compatible to your Kubernetes version. I meant to say, here we see that at the time of me downloading the kubectl, I'm mentioning the version as well somewhere here, right? The Kubernetes says the kubectl version should be closer or equal to the Kubernetes version. Let's say if your Kubernetes is 1.28, try to use kubectl also 1.28, then it will be a best match. If you are using kubectl 1.25, maybe Kubernetes running as 1.28, it may not work. So we need to see the compatible kubectl client only, then only it will work. That's what it is explained here. Let me see which Kubernetes client that I'm using here. kubectl version. You see, I'm actually running with 1.28 version. My Kubernetes also running with 1.28 only. So both are same. It is working for me. Now onwards, it's just a matter of using the kubectl command and talk to the API server and inform to API server where and how your application should run. Done. That's the story for today, but let me run one simple command now. Let's say I wanted to run my Apache HTTP web server on my Kubernetes. All what I can do now is kubectl, right? kubectl run and specify the image name that I wanted to. Sorry. What is the syntax, guys?
Pod name, right?
Not name.
Yeah, so there is no flag over there. Okay, so it will be a run, then specify the name of the application. That's it. That's it. It's done. So what I did, I'm just telling that, hey, use this HTTP image and please run the application, and web is my application name. In a way, this is a pod name now, right? Because we always create a pod from the Kubernetes perspective, right? So it is now actually created a pod. In the sense, inside the pod, yes, there is a container. Inside the container, the Apache HTTP web server is actually running over there.
So, sir, this HTTP image, from where did you pull it? Did you pull it from Docker or is it from the registry of provided by
Same
AWS?
Anything related to the Docker concept that I talked about before will still be applicable here as well. Is mean that if you are not specifying the image has to be pulled from where, by default it will be pulled from the Docker Hub registry, because who is pulling the image, guys? It's still a
AWS.
container, right? Sorry, container runtime.
Yeah.
Hence the reason that concept remains be the same. It is trying to download it from Docker Hub registry by default if you don't specify any explicitly. And now I can see my uh, uh, pod is running there, and I can see the pods that are currently running in over there. That's it. My pod is running. Inside the pod, container is there. Inside the container, application is there. My website is up. How to access it? All those things we'll definitely see in tomorrow lecture. For now, the kubectl run command is equivalent to docker run command. Kubectl get pods command is equivalent to docker ps command. Make sense?
So the command that you have given, run web image HTTPD, how will I mention whether it will run in node group 1 and node group 2?
Of course. As a sample, I ran that command today just to show how quick it is to run it. We'll talk about the best practices start from tomorrow, because it is not going to be as simple to run a command as I did it now, right? We'll be doing a lot of best practices start from tomorrow. We'll do all of exercises.
Okay, so there is a way that we can mention that which node group I want to install the XYZ
Yes.
application.
So as of now, where it is installed, guys, I'm done for the today lecture, guys. I'm just going through the questionnaire, and we'll talk about the best practices tomorrow. As of now, my pod is running on the worker node. The worker node ends with the so-and-so name. So 118, which is 118 in this. If I go to EC2 instances, yeah, you can see the 118 somewhere here, right? So this is the instance where my application is currently running in. So Kubernetes has chosen this as a preferred node automatically by the scheduling policies. That's how it works. Yeah, so how to access this application from your browser, all these things we'll see start from tomorrow, guys. We'll look into that.